pick a different one. Okay. All right, so this is single displacement. In your notes on types of reactions, that right here is single displacement. I have the element reactivity series, or you do here in your notes, and it says see my video. This is the video. So single displacement, they tell you in the notes that single displacement is AB plus C yields CB plus A, okay? So the C comes in and knocks the A out, okay? So the C takes the place of the AB ends up by itself, the C ends up in the compound with B, okay? So that's single replacement. Single replacement, single displacement, it's the same thing, you hear them both, okay? Again, makes sense because one single thing is replacing something else, okay? You can also have this. Where the C comes in and replaces the B. That was nice, Abby. Sorry. Where the C comes in and replaces the B. Okay, so that means that C is negative. Here, C is positive because we know that what comes first in our compound is positive. What comes second in our compound is negative. So if C is negative, negative replaces negative, positive replaces positive. Okay, so you have over here then is AC plus B. So the C comes in, knocks the B out, and the A goes with the C. That's going to happen down here where it says halogen reactivity. That's the second one. And we don't have to worry a lot about that. We're going to worry much more about these ones, but you're going to see one of these, so I wanted to throw it in there. So let me explain how this works. So let's say we have 2Al, and Al is a solid because it's by itself, and it's aluminum, and it's a metal. Metals are solids. Plus 3CuCl2, and that's aqueous because it tells you in a minute, or in the next video, you'll know how to figure it out. Yields 2AlCl3, aqueous, plus Cu solid. Sorry, this is 3Cu solid. Balanced, has all of our solids, aqueuses, liquids, gases in there. We're all good. Okay. This is obviously single replacement because what's happening here is the aluminum is coming in, knocking out the copper. Okay. So over here, the copper is by itself, and the aluminum takes up with the chlorine. So you have a single replacement or displacement there. Now here's how you tell whether this is going to happen or not. Okay, you can predict it, but then you have to decide using your element reactivity chart whether it's actually going to happen or not. Aluminum wants to come in and knock out copper. Okay, again, aluminum's positive, copper's positive. Okay, so aluminum positive knocks out positive, or tries to knock out positive. So aluminum, copper. You find aluminum on your element reactivity. Aluminum's right here. Okay, then you find copper. Copper's down here. Aluminum is above copper in the element reactivity or the reactivity series. It's called a lot of different things, activity series. Because aluminum is above copper, it's able to knock it out. Okay? So because aluminum in your reactivity series is above copper, this is going to happen. So you're going to have a reaction. Now, what if you had this? Oops. Sorry. That would be a solid, that would be aqueous. Okay, so what if you had that? Now you have copper trying to come in and knock out sodium, right? Because positive tries to knock out positive. So we go back to our reactivity series. We find copper. Copper's way down here. Sodium's up here. So copper is below sodium, which means it's not going to be able to knock it out. So your answer here is going to be no reaction. You're going to see me write it like that all of the time. RXN is reaction. You'll see me write it like that all the time. You'll see it written like that all the time. So there's no reaction that happens here because, again, copper's way down here. Sodium's way up here. Copper way down here. Sodium way up here. Which means copper does not have the strength to knock out sodium. So nothing is going to be able to knock out lithium, correct? Rubidium is the only thing, or I'm sorry, rubidium, or lithium's the only thing that's going to knock out rubidium. Lithium will knock out rubidium and potassium. See what I mean? As you go down. If you're doing these ones on the bottom down here, the halogen reactivities, you have to look at it like this. So let's say, let's see if I have an example here. Thought I did. I can make one up. Okay, so let's say you have this. And you want to know if there's a reaction. Okay. Fluorine's negative, so it's going to come in and try to knock out the negative. Okay. So what you have to do is you have to go down here and you have to determine whether fluorine is going to be able to knock out iodine. It is, because fluorine's on top and iodine's on the bottom. Fluorine is the most reactive. Okay. So you're going to end up with CaF2. That'll end up being aqueous. Plus I2, which is a gas. And then you'd have to balance it. Well, actually, I think it is balanced. It is. Okay, so, but that's how you would do it that way. Again, there aren't many that are like that. Most of them deal with up top with their positives, but I wanted to show you a negative. Okay? Send me a reminder with any questions.